Greetings. My name is Dominic Fabian, matrix number 83679, and I'm going to be presenting for AvoScan, which is my final year project, an interactive AR mobile app to scan avocados ripeness using UiUX approach. For the introduction and project overview, this project proposes the development of a mobile application using augmented reality AR to access the ripeness of avocado. The application also enables users to scan avocado using the smartphone camera, where the system analyzes its color, texture, surface character to determine whether it is unripe, ripe, or overripe. Through this technology, the app aims to assist consumer home cook in quick, accurate, and well-informed decision when selecting avocados for consumption. So the concept for it is for smartphone application using AR image analysis to judge avocado ripeness non-destructively. How it works, the app uses phone camera to analyze color, skin pattern, surface character, and also the goal is to assist consumer and home cook in making quick, accurate, and informed decision when selecting avocados. For the problem statement, we have that it is difficult for consumers to tell certainty when avocado is matured enough to eat. So one of the problem can be visual difficulty. Consumer find it difficult to determine ripeness just by color and texture. Unreliable manual method, such as squeezing the fruit, because to know if the fruit is cooked, it's going to be a bit squishy. If it's not ripe yet, it's firm. So it can really cause damage to the fruit. And accessibility gap, uh, users aren't able to access for like high accuracy tools like hyperspectral imaging, which is often limited to laboratory environment and not accessible to average user. So the app is simple, user-friendly mobile app for accurate ripeness check. For the scope, uh, this project focuses on development of AR-based mobile application, detect avocado ripeness through image processing and computer vision techniques. So image capturing through smartphone, analyze the color, the texture, and the pattern of the fruit, and also real-time AR visualization in ripeness level, telling unripe, ripe, overripe. The system will be tested on different avocado samples under varied lighting conditions to ensure accuracy, and the project does not cover other fruit types or hardware-based sensing methods. To develop an AR-based mobile application accurately that can determine the ripeness of an avocado based on color and texture, the objective is to identify, to apply image recognition and color analysis for accurate ripeness detection result, to design and develop an AR-based app that scans and detects the ripeness of avocado using camera, to evaluate the application usability and perform through an AI approach, which focus on user satisfaction, interface simplicity, and real-time responsiveness. For literature review, the key focus is examining current research and transition from manual to digital assessment. So we can see here manual versus digital methods. Manual inspection consists of touching and by sight through the human eye. It is subjective and leads to fruit bruising and waste, while digital method aims for non-destructive and objective analysis based on the color and texture of the fruit. Use standard RGB images to categorize ripeness stages, which limitation highly dependent on perfect lighting and static background. For gap analysis, the problem is most current app identify what fruit is, but not how ripe it is, while the AvoScan solution bridging the gap by bringing real-time AR feedback to average consumer, which focus on UI/UX design to ensure technology is actually usable in grocery store settings. For research methodology, we are using the agile approach. The agile software development adopt to support iterative development, frequent testing, and continuous feedback. Why Agile for AvoScan? Complex tech stack manages the integration for computer vision, real-time AR, and camera interaction. Refinement allow for continuous improvement for both functional ripeness accuracy and non-functional UI responsiveness requirement. Sprint-based development, each cycle focus on incremental features, which is from camera scanning, ripeness clarification, AR visualization, and result presentation. There are three pillars ensuring structure, speed, and mobile optimization. The first is SDLC, structure, provide the fundamental life cycle for requirement analysis and system design to development, testing, and maintenance. The second one, RAD, speed and prototyping, focus on rapid mockups of scanning screen and AR overlay to gather early user feedback and reduce development time. The third is MATLC, mobile optimization, ensure app is tailored for mobile specific needs such as design, optimized for one-hand operation in grocery store, and testing, compatibility, check across different screen size and camera qualities using Android or iOS. Based on a quantitative survey result that has been gathered, data gathered from 42 respondents validating the need of AvoScan. Here we have the problem that which is 71.4% of users occasionally buy avocados that aren't expected ripeness. 51.1% still rely on squeezing, which is subjective and damaging. Demand for AvoScan, 81% of respondents stated they would use the mobile app to scan avocados, and 97.6% support the use of AR visual indicator color labels for clarity. So the user priority is top features, specific ripeness level, unripe, ripe, overripe requested by 64.3%. Purchase impact 66.7% agree that app would directly influence their final buying decision. For system requirement and specification, functional requirement, real-time scanning, feature analysis, ripeness clarification, categorized in three stages, unripe, ripe, or overripe, AR visualization, display result through intuitive augmented reality overlay, non-functional requirement, performance, fast response time for instant scanning in retail environment. The accuracy has to be reliable detection in the supermarket lighting condition. Usability, simple, intuitive UI design for one-handed use while shopping. The hardware requirements is user devices, which is using Android or iOS smartphones, equipped with high-resolution camera, development tools, high-performance computer for AI model training and testing, connectivity, stable internet access for system updates, and model optimization. Next, we have the system design, use case diagram. Primary actor is the user. Core function includes scanning avocados, viewing ripeness result level, receiving storage recommendation, and viewing usage suggestion. And the goal is to emphasize simplicity and direct interaction with AR scanning feature. Next is the sequence diagram. The modules, interaction between user, AvoScan app, image processing module, and ripeness analysis system. The process, user initiates scan images, is analyzed for color texture. Results are returned to the app and the real-time feedback is displayed. For the activity diagram, users will open app, start scan, capture avocado, analyze ripeness, and it will show ripeness. So if it shows overripe, and the decision will be made by the consumers whether to buy or not to buy, show unripe, show ripe, or show overripe, it depending on the user's preference of what ripeness do they want for the avocado. For class diagram, we have user, scan, images processing, and also ripeness result. So the responsibility manages users' interaction data, scan action, which is capturing and initiating analysis, and the output result data. So this is the user design interface. So the design interface is illustrated to wireframe, which emphasizes simplicity and clarity that ensures smooth user experience in fast-paced environment like grocery stores. Here we can see scan, start scan, and then it will pop out to open camera. After scanning the fruit, it will analyze. After analyzing, it will give out feedback whether it's unripe, ripe, or overripe, and we'll put out a description there telling how many days will it go ripe and whether to buy it if it is ripe. That is all for me. Thank you.